Welcome to Mpirical's NetXLabs. Now, NetXLabs is built on Open 5GS and utilizes the UE RAN SIM software to enable the users to interact with the simulated device such that they can trigger key procedures like registration, PDU session, pushing the device to idle mode, etc. And the idea is, whilst doing that, we can capture the wireshark traces. Now, it's not just about capturing traces. NetXLabs is about learning the key protocols, procedures, and interaction that you would see within a 5G RAN and a 5G core. Now, diving into the dashboard, you can see it presents you with some of the latest lab exercises that you're looking at. There are a number of lab exercises. Now, I will say you don't dive in straight away into what is a Amazon Web Service instance utilizing an Open 5GS lab. The labs build on each other to aid learning. So the first lab is more of an orientation, so a quick video introducing the lab, and then we start the learning process. So lab 2, as you can see, is architecture and protocols. Again, depending on your background, it will start leading you through the various protocols. Now, a lot of the exercises are based on Wireshark. So you do need access to Wireshark on your PC. You'll be downloading the Wireshark traces from the AWS instances. So the next lab exercise makes sense to be 5G in Wireshark. So there's no point in doing some of these exercises if you don't know how to drive Wireshark a little bit with respect to 5G filtering of key protocols and identifying correlation of key protocols. So we introduce some of the basics of Wireshark. It's not about capturing, it's about analyzing. Then you can see lab 4, 5, and 6 walk nicely through the various protocols you might find within a Wireshark trace. So you can see we've got device protocols. So this focuses on RRC and NAS. Now you might say, well, where's the RRC protocol? Well, as part of UE RAN SIM, you'll get an element of RRC interaction. There is a plugin for Wireshark to enable that to happen. You've got the RAN protocol, so NGAP and specifically SCTP, the Stream Control Transmission Protocol, is discussed as well. We then dive a lot into the core protocols. So core protocols are looking at things like the HTTP2 SPI interactions, service-based interfaces, as well as things like PFCP, the Packet Forwarding Control Protocol, to the user plane function. Now, at that point, you should be at a good enough level to then do some more analysis on the live system. So the first key lab is lab 7, where you start using, as it says, live NetXLabs. You start having an instance in AWS. So you can see, as you can see from the labs, some of them are based on Wireshark. So if I go to device protocols, for example, what you're going to get is a mixture. You get a mixture of information. You get a mixture of video content, you get a mixture of diagrams, and littered throughout the various lab exercises are various tasks and questions to answer as well. And this all is tracked. As you can see, you get little tick marks and you get progress, and you can identify what you still have to do for, again, particular lab exercises. Now, just going back to the labs, you can see some of these lab exercises, especially the latter lab exercises, use AWS. Now, at this point, you will be asked to connect to an AWS instance. So you can see if I just tick the box there, you'll see my traffic lights move up, and we're now interacting with the AWS system. You can see a timer. Don't worry about that. That's more to do with, so we don't just leave it 24/7. So the idea is towards the end of that timer, you'll get some pop-ups to say, would you like more time? And you just go, yes, yes, and you can carry on more time. The key thing here is you've got your instance of a 5G core that you're working with. Now, it's only active whilst you have this lab open. So you're in this particular lab exercise, you will have an instance open. If you move from one lab to another, you close the instance and you start a new instance, because the idea is we need to start with the common, if you like, configuration. As you go into the practical aspects, you can see we have the ability to connect, and this is where we have a Linux-based interface, so you can have commands that you can put in to trigger certain procedures. And at this point here, we've got various simplified menus put in place so that the end user doesn't need to know all of the Linux commands. Later on, you can learn more of the commands, but to start with, we have a menu structure to help us do key basic tasks like starting the 5G core. We can do that quite easily. We've got the ability to start the base station. And at this point, you can see the base station has been started. You can see some interaction. Now, I will point out in some of the lab exercises, including this one, you'll be capturing that as a wireshark trace and doing some analysis on it. But we also have the ability to do various procedures like trigger the registration procedure. So you can see the device going through the various stages of registration, security, triggering a PDU session in this example as well. And more so, using multiple terminal windows, we have the ability, again, using the menu structure, the ability to interact with the device. So we can trigger certain things. We can get information about the status of the device. We can get information with respect to the device and its identities and its 5G GUTI, for example. But we can also interact with the device, for example, triggering it to be pushed into the idle state. So we have this ability to change the state. And each time I do that, you can see on the terminal window 1 here, the state is changing. So we're actually interacting with the device as we are going through these lab exercises. And all of that we can then capture and then do some post-analysis on within Wireshark. So it's very interactive with respect to that process. Now, occasionally, like there, the device is obviously a simulated device. It will trigger the ability to come back onto the system. Service requests, things like that will be covered as well. So just going to the lab exercises, I was on the G Node B setup. As you can see, that gave me a terminal window. Each of the following labs, the registration, security, PDU session, linking into service requests, all of these are structured labs building on each other so that by the end of it, you've got a good fundamental understanding of all the protocols, how to interact with the device, but also looking at the Wireshark traces. So they each build on each other. And that sort of summarizes the various labs that you have in the NetXLabs instance. Going back to the dashboard very briefly, it's also worth pointing out in the first version of the NetXLabs, it's quite static with respect to configuration. There will be some more lab exercises going in where we will start looking at things like YAML configuration and the ability to effectively troubleshoot and interact with some of the configuration information. So you can see, you can go in and start looking at the YAML files that we have got configured on the live system. So you can interact with that. Just going back to the dashboard, it's also worth pointing out, you can see that you've got progress information. We also have the actual implementation, the actual reference map of our Open5GS and UE RAN SIM. And the idea is, as you're looking at Wireshark, all of these IP addresses are distinguishable, and you can actually see what's communicating between the various functions. Now, I will point out, it's just early days. You know, we're building more labs, building more, if you like, interaction in terms of some of the configuration options. So throughout the year, there'll be additional lab exercises being added, again, as we build into different areas of the NetXLabs.